Hi, my name is Dr. Adiv Paradise. I'm an astronomer, and I'm also a sci-fi lover and enthusiast. Ever since The Magic School Bus and The Brave Little Toaster Goes to Mars when I was a little kid, all the way through Battlestar Galactica, Star Wars, and Mass Effect, I've loved science fiction every step of the way. Time travel is technically possible, and really, I should say, we are traveling in time right now. We're just going forward into the future at a fairly normal rate, at least normal as far as we're concerned. But time travel is also possible, maybe, in a couple different ways. We could go faster into the future by making use of things like time dilation or gravitational wells. And we can maybe go backwards into the past with things like wormholes and closed time-like curves. One way that we could go faster into the future is through something called time dilation. If you go fast enough, then Einstein's laws of relativity state that the amount of time that passes for you will be less than that for somebody watching you. So for example, we see this most often with what's called the twin paradox, which is not really a paradox. What happens is you take two twins. One twin gets on a spaceship and travels at nearly the speed of light. And when they come back, potentially 100 years has passed for their other twin, and their twin is long dead, while they've only aged a few days or maybe a year. Another way that this can be done is gravitational time dilation. Time passes differently depending on how close you are to a massive object. And this is very real. The surface of the Earth is actually about 2.5 years older than the core of the Earth. This is also true for satellites. GPS satellites experience time faster than we do here on Earth. And they have to account for that when they calculate our positions. So in a sense, we are all currently on a time machine traveling a little bit faster into the future than the rest of the universe. Traveling into the past is a little bit trickier. Now, Einstein's theories of relativity technically permit it with something called a closed time-like curve. To understand what this means, imagine that you draw a map, and in one direction on the map is distance, and on the other direction is time. Now, usually, we can only sort of go in one set of directions on that map, in a little narrow cone, and we call this a light cone. And for most things in the universe, all of our experience lies within that light cone. Go outside the light cone, and that implies traveling faster than the speed of light, something that's not allowed. But what if you could draw a line that's a circle on that map? Start at one point, go in a circle, and end up back where you started. That would technically count as time travel backwards in time. There are solutions to Einstein's theory of general relativity that permit closed time-like curves. For example, a rotating black hole, there are regions around it where it's possible to have a closed time-like curve. Another possibility would be taking a wormhole. If you could take a wormhole, which you can think of as kind of like building a bridge between two parts of the universe, punch a hole in one and connect it to the other part of the universe, and then link them together like a thread tying a stitch. If you could take one end of a wormhole and then move it through a region of time dilation, either by moving it very quickly or moving it through a gravitational well, then because time moves less quickly for that end of the wormhole, by the time you're done, one end of the wormhole is younger than the other. And you could then chart a path through that wormhole, and when you emerge from the younger end, you would have traveled in time. The challenge to this kind of technique is that, for one, you could only ever go as far back as when you first created the time machine. You couldn't go any further into the past. It's also not entirely clear how you would do this. And this is where we have to remember that when we're talking about time travel, there's a difference between permissible and possible. Einstein's theory of relativity may allow time travel, but that doesn't mean that it's possible in our universe. Maybe the energy requirement is just not possible, or maybe wormholes don't actually exist. That would be a big roadblock to making this work. The consequences of time travel depend on what kind of time travel you're doing. If you're going into the future at a faster rate, then the consequences are fairly straightforward. You get to see more of the future, and the people you leave behind get to see less of you. If you have a twin, you and the twin stop being the same age. We see this in the film Interstellar, which quite accurately shows what happens if one person goes down into a deep gravitational well close to a black hole and another person stays away. What may seem like only minutes for one person might be years for another, and there's no way to undo that. If you're trying to go backwards into the past, then we start getting into the stuff of which science fiction is made. And this is where we get into paradoxes. Could you go back into the past and stop yourself from going through the time machine in the first place? When you're talking about a closed time-like curve, by the very definition, you're coming back to where you started. We don't really know what the answer to this is. Some scientists speculate that maybe we just don't know enough yet. Maybe there are changes to the equations, to the theories of relativity that we haven't discovered yet that make time travel impossible, and therefore we don't have to worry about this. Maybe there's some kind of mechanism that makes it impossible to cause a paradox. Maybe things always have to happen as they did. Or maybe another explanation, the explanation that I call the do it and hope nobody notices explanation, is maybe there are paradoxes. Maybe you can break causality, but maybe it's not possible to observe that. Maybe the way the universe works, you can cause all kinds of problems when you go backwards in time, but none of it is ever actually noticeable. Maybe nobody could ever actually catch on. Or maybe causality just isn't as important as we think it is. There are a couple of projects underway to explore some kinds of time travel. For going faster into the future by traveling at relativistic speeds, there are people actively working on how can we build a spacecraft that go fast enough that we could visit other stars, potentially within human lifetimes. Project Starshot is a good example of this. Could we build a very, very large, very thin, lightweight solar sail and send it with a giant laser to a nearby star? That's a project that is maybe feasible within our lifetimes. There's another project, however, making use of what's called an Alcubierre drive, and this is much more experimental. The idea there is that the whole restriction on the speed of light that limits how far and how fast into the future you can go, and that makes it hard to travel in close time-like curves, that rule only applies locally. It's entirely reasonable for different parts of space itself to move faster than the speed of light relative to each other. And there is a group at NASA that has been working on exploring, could we build a drive that just moves space itself? Because if you can create a bubble of space and just move space, then you could go faster than the speed of light. And if you can go faster than the speed of light, then technically you could potentially make a closed time-like curve. Regardless of whether or not time travel is possible in real life, it's really fun to explore in fiction, to go either backwards in time or forward in time. Now, personally, I don't think I want to go back in time. And the reason is that, in reality, life has been getting better for humans pretty consistently throughout time. Go too far back in time and diseases become a really, really big danger. In Michael Crichton's Time Machine novel, that's exactly what happens. I would prefer to go into the future. I would love to see how things play out. When I was a kid, I loved reading H.G. Wells' The Time Machine. And seeing this imagination of how do humans evolve? How do we look different? How does our society change on timescales of centuries, millennia, and millions of years? What happens as we explore the cosmos? I would love to know the answer to that. There are so many questions that will not be answered in my lifetime. Even my core research question that has motivated my PhD: is there life out there, and what might it be like? What might alien worlds and their climates be like? We won't know the answer most likely in my lifetime, and I would love to travel forward in time and see what that looks like.